Now let's talk about the question number 52. In this question we are given the joint density function of a random vector xy, and we are asked to find out the covariance between x and y. We know the formula for covariance between x and y. It is equal to expectation of xy minus expectation of x multiplied by expectation of y. In order to evaluate these values, we need to first find out the marginal densities of x and y. So as usual, we begin with the marginal density of x. In order to find it out, we just integrate with respect to y within the given limits. I mean, the limits are between is the limits are the boundaries of the given region. I mean, there are two parabolas. So just integrate with respect to y between these parabolas, and it finally turns out that x is a normal random variable having parameters 1 and 1 by 2. That means x has the mean 1 and the variance 1 by 2. So as x is a normal random variable, we can express x as equal to sigma z plus mu. That is, x is equal to z by root 2 plus 1. Okay, that's all about the marginal density of x. Now we can try to similarly find out the marginal density of y, but it turns out to be extremely difficult. So instead of finding out the marginal density of y, we will find out the conditional density of y given x. We know the formula for that, and just find it out, and it turns out to be equal to root pi. So we get the value, we get the expression for this conditional density of y given x. Now we can find out expectation of xy, expectation of x, and expectation of y. What is expectation of x? We know that x is a normal random variable, so expectation of x is equal to 1. Now we can find out expectation of y using the conditional density, using the formula expectation of y is equal to expectation of y given x. Okay, so first we have to find out the expectation of y using the conditional density. So just find it out, and then we have to again find out the expectation with respect to the density of x. So it turns out that expectation of y is equal to expectation of x square. Okay, but we know that x is a normal random variable, so what is expectation of x square? We can find it out using the formula for expectation of x square, and we will finally get that expectation of y is equal to 3 by 2. Similarly, using the conditional density, we can find out the expectation of xy. Expectation of xy is equal to expectation of xy given x. But since we are first evaluating the expectation with respect to y, we are integrating first with respect to y, so we can take x outside the inner expectation. Okay, so this formula becomes expectation of x multiplied by expectation of y given x. That means expectation of x, expectation of y given x. It becomes expectation of x, expectation of y given x. So but we already calculated expectation of y given x. It is equal to x square. So expectation of xy turns out to be equal to expectation of x multiplied by x square. So that is equal to expectation of x cube. Now we know that x is equal to z by root 2 plus 1. So expectation of x cube can be calculated to be equal to expectation of z by root 2 plus 1 the whole cube. Now just expand this formula, expand this expression using the formula of a plus b whole cube. Now while doing this expansion, we have to keep in mind that the nth moment of the standard normal random variable is equal to 0 if n is odd. We have to keep it in mind. So we do not have to consider the first power of z and the third power of z. Just retain the even powers of z only. So we will get that expectation of x cube is equal to expectation of 3z squared by 2 plus 1, and it is equal to 3 by 2 plus 1. So we finally get that expectation of xy is equal to 5 by 2. So we know all the necessary values in order to evaluate the covariance of x and y. So what is it? The covariance is equal to 5 by 2 minus 1 multiplied by 3 by 2 is equal to 1. So the covariance is equal to 1. So we get the final answer as 1. The answer is 1.